Right, welcome back to part 2, and we'll continue on with question 5 of tutorial 4, and we're looking at logs and exponentials. So, in each of the following, make each the subject, make y the subject. Okay, so before we go and do something like making y the subject, what we'll need to do is consider any pre-work that needs to be done. Now, our instincts tell us that we've got to disconnect the log 5. And how do we undo log 5? Well, we would take 5. But before we do that, perhaps we should dissolve the two-term log expression on the right-hand side. So a little bit of pre-work before we do the big thing. And that means that these are sums so they can become a product. Log base 5. Now we just have a simple 2x. And this one over here. So now we can do the big thing, which is undo. How do we undo log base 5? Well, base 5 tells us that we take 5 to the power log base 5. And what does that do? Undo. Don't forget your y. And what we do on one side, we do the other. Log base 5, 2x. So now we've got 2 undos. Look at that. 2 undos. 2 undos. So we're getting in the habit of just making some very straightforward work of it, rather than worrying too much about it. Just get on and do it. Okay. So in the case of B, we've got again there'll be some pre-work to do. I won't make a big song and dance about it, but the fact that you get your change of base from numbers to pronumerals doesn't matter. Just go ahead and do the undo part. Do whatever pre-work needs to be done. Okay, so we've got log bases. Now it's a subtraction, so it's 7 over x. We could put a bracket, not going to bother. So log b y. So now we've got undo. So we're going to take b and the log of base b. There you go, that's the power. Don't forget your y. And what you do to one side, you do to the other. Don't forget to do that. What you do to one side, you do to the other. So that means they all undo. The log b, the b log b's will undo. There they are. And so you'll be left with y. The b log b's will undo. And so you'll be left with 7 on x. Easy. Very straightforward. Okay. So just manipulating gymnastics, that's all it is. It's once you learn how to do it once, you can just press on. Okay. So log base 3 y again. 2 log base 3, 7 minus log base 3, 8. So before we can do the joining together, we need to notice this. So we put it up. So we get log base 3, 7 squared minus log base 3, 8. At this point, we can do a 7 7 to 49. So we'll see that that's a quotient. So it'll be log base 3, 7 7 to 49 over 8. Log base 3. So this is the long way teacher who does every step. And now we can take undo 3. How do we undo log 3? We raise it to the power 3. There you go. Log base 3 y. That's undo. And likewise, both sides, please. Don't forget your quotient. Okay, and then they're both 1, and so y is equal to 49 on 8. Very good. Okay, very, very good. So without too much trouble, we're getting through them. So D and log base 4 this time. And of course I let the students in the class take the lead and work through all of these. And so whether it's me doing this or a student doing this, on one level probably doesn't matter too much. Plus log base 4. So I had a student interestingly come and help me with this question because if we take care with this, we can see that there's possible. Now which one do we do first? Do we do the minus first or do we do the plus first? Not sure. Which one do we do? So why don't we do both? Why don't we split that up and do both? We'll do one and then the other and see what we end up with. We get log 4y. We're going to do this one over here, so it'll be a minus, so it'll be log base 4 with the x on 5 plus log base 4 3. Over here we'll get a log base 4 starting again equals, this time we'll do the plus, so we've got a log base 4 x, and we're going to do a minus log base 4 a product. 3 by 5 is 15. Now we can do this one and we can do this one. Let's see where we end up. So we get log base 4 y. They're a sum, so we're going to end up 3 times x over 5. So log base 4 3x. 3x. So it's, if you think about a product x 5 3, what would you end up with? 3x over 5. 3x over 5. Okay, over here we've got log base 4y, and we're going to get log base 4. Now it's a subtraction, so we're getting x over 15. Now, in the first instance, what have we got? We've got 15. So we'll just see what we can come up with there. This is where I think I had a stammer in the class when we looked at this side and did that one first. So let's come back over here. Now we've done enough work there. We can undo log 4 with the 4. So we can do log base 4 y and 4 to the power log base 4 3 on x over 5. So that's undo. That's also undo. And so we're left with y equals 3x over 5. Alright, now, when we do the product, in the first instance, we did minus log 5. Now, this was the thing. The minus out the front was ignored, wasn't it? And it should have been lifted up. It should have been lifted up, perhaps, to the top. Or at the very least, that would make 5 to the minus 1, which would put the 5 on the bottom. And in which case then, you would have 1/5, you would have 3 over 5. 3 over 5 wouldn't be 15. So this little interlude here tells you that this minus is being distributed across both of them. So you've got to be very careful when you're doing which choice to do, because this is clearly not the same answer. So this side didn't take into account. It's a bit like doing this. It's a bit like subtracting. Let's do an algebraic version. Let's do A minus B plus C. A minus B plus C. And then what we're saying is, let's do B plus C and just have the minus there. But we didn't take into account that it's actually minus B. So we have to process this as a minus B. Now in the log rules, that means this has got to go up to the top. So there's an intermediate line here of log base 4, 5 to the minus 1, which is also 1 over 5, plus log 4, 3. So in actual fact, that's the more accurate version. And then our log 4 remains out here, this one here, log base 4 of x. So that's actually now become a plus. So in doing this, you need to be careful not to make that error. Okay, so that's 1 over 5 as a product. So if we do that, that's in actual fact, let me just take this one away, just to clarify what happened with that. So you can be careless, and I think I was careless in my own tune when I did this. So 3 and 1 over 5 with a plus, okay? And this is still in play, this is still down here. So we'll remove the other one. We'll process that one. So this would be equal to log base 4x. This is now a product. So it's log base 4 3 over 5. And the reason is because this would become 1/5. Now that's a product. 3x over 15. This is the same as the other side. So taking 4 to undo the log. And taking 4 to undo the log. So you need to be very, very careful. Undo, undo. Y is equals to 3x over 15. So please be careful in choosing which order you do. Just doing that ignores the minus. That's not correct. Okay, so you have to be very careful when you're doing which one you do. So it was expedient and helpful to do the minus first. Okay, as an algebraic sense, because we didn't have to consider the negative rule there. So very interesting, very, very interesting question. Anyway, looking for E, 4 log base 2x minus 3 log base 2y equals log base 227. So in actual fact, what I'd like to do is take this over the other side, just as I would with any equation, and subtract this one, just as I would with any algebraic equation. So we'd have 4 log base 2x minus log base 227 is equal to 3 log base 2y. Now we need to move the y, we need to move this power over, and we also need to move this power over, and then process the minus. So we can take the steps to do that. So we'll get log base 2x to the power 4 minus log base 227 equals log base 2y squared. Now we can undo the logs. It's all base 2, so we can put them to the power. Oh, wait a minute, we've got to do the product. Nearly did it to myself. So we've got a quotient here that we need to deal with. Now we can have done that pre-work, we need to do this pre-work. So log base 2 is going to be the numerator divided by the denominator equal to log base 2. Now we can do undo. Taking 2, undo, x to the 4 over 27. What you do to one side, you do to the other. y2, there undo. And so we're left with x to the 4, 27 is y squared. Now we can just algebraically manipulate this. So y squared is equal to x4 over 27. Now, was it y squared or y cubed? Sometimes do this. Now look at that. That 3 went up as a cube. So I'm just having to check myself. It's a 3. So to undo, we're going to take the cube root of both sides. So we'll get y equals the cube root of x4 over 27. We'll split this in 2. We'll get the cube root of x4 divided by the cube root of 27. Now 3 3s and 9 3s are 27. So the cube root of 27 will be 3. And so we'll get the cube root of x4 over 3. That's our final answer. So a lot of gymnastics, that's all it is. It's just undo, 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 undo ad nauseum. Undo ad nauseum. Who knew high school algebra was all about undo? So there you go. Come to uni and find that out. Perhaps we could get them to do it at school. Okay. Okay, so log 5 plus log 7 equals log 35 C, sorry, that was A, 6A, 6B, log 200 minus log 40 is log 5, and finally the check they want is log 64 is equal to 3 log 4, which is equal to 3 log 5, which is equal to log 4 cubed. I would have thought that was all easy. Log base 10 and log base E, which is equal to ln. So they want to check both ways. So I'll need to store the right hand side and check that the memory recall fits. So if we take the log of 35, we take 35, take the log base 10, which is log, and put that in the memory. Then we can do log 5 plus log 7. So take 5 log plus 7 log equals. Now the memory recall shouldn't change that number at the top. So if I press memory recall, didn't change it. So tick. Now we'll do it again for ln, because it's showing you that the next step is going to be the change of base formula. You can use either. Okay, so we'll clear all of that. We'll clear the memory recall, and we will put ln. Now we're going to do ln. So 35 ln, put it in the memory, it's a different number, but we're doing 5 ln plus 7 ln, a ln of 7, there they are, ln 5 plus ln of 7 equals, that number shouldn't change. So if I do memory recall, well actually I can see it there, ln 35 in the list, but you might not have a list like that, so I'll do memory recall just to show you that it doesn't change. Okay, it's the same one, so we can tick that one as well. Log base 5, so we can do that one, just clearing the memories, cleaning the slate. 5 log, just add that to the memory. Now we're doing log 200 minus 40 log is equal to 0.698 to a memory recall. Same thing. Now this time here I'm going to change this into its other form. It'll be 200 divided by 40. So 200 divided by 40 is 5. But guess what it's going to be? Memory recall, same number. Okay? Do the same thing with ln. 5 ln, put it in the memory. Now we're going to do 200 ln minus 40 ln is equal to memory recall, please. Same number. Okay, it's the same. So for both log and ln, we can say that they're the same. Now whether you use 3 lots of log 4 or it doesn't really matter. It's only important that you do one or the other. So we'll do this one, arrays. No, I just want to get rid of that. Cool. There you go. So either way will work. So we'll clear the memory, clear the stuff around, clean the slate, and we're ready to go again. So we're doing the result, or the left hand side, which is either 3 log 4 or log 4 to the power 3. So we can take 4 to the power 3, which is 64. We can take the log of that and put it in the memory. Okay. The next thing we'll do is take, well, we did 64, so it's pointless. Either way it works. Okay. So we can be satisfied that they're both working. Okay, very good. Evaluate each of the following two decimal places. So Houston, we have a problem because how do you do log 5 on the calculator? You can't. But what we learned about in the workshop was that we can take either the log, put that on the numerator, divided by the log of 5, which would be the same as taking the ln, divided by the ln of 5. So we can do that readily, just as we did previously. So log 29 divided by 5 log is 2.09, so we'll put that in the memory. 29 the ln divided by 5 the ln is equal to, now memory recall shouldn't change it, it didn't, 2.09. Okay, so very straightforward, 2.09. So the change of base formula is very helpful because it can take formulas that we're not familiar with and pop them in using our calculator, which we are familiar with. All right, so B log 3 98, it's going to go up, down, so we're going to get log 98 over log, 3, that should have been there, or ln of 98 over ln 3, either one will get you the same result, and so 98 ln divided by 3 ln is 4.17, 4 will go down, 3 will go down, so we'll get 4.17 to 2 decimal places. And C is log base 7 311. Now you can change this into its parts if you want to, or you can just continue on. Log 3 on 11 is on the numerator, or ln 3 on 11 is on the numerator, divided by log 7, the base, which is also equal to the ln of 7. So you just do the bracket operation first before you do one or the other. So just clearing away all of this stuff. So we're going to go to 3 divided by 11 equals, and we'll take the log of that, and we'll divide that by the log of 7, minus 0.666. Okay, we'll do it again. 3 divided by 11 is equal to, now we'll take the ln of that, and we'll divide that by the ln of 7. That equals the same number. So there's our first result. Okay, divided by log 7, 3 divided by 11, and we log that, and so we got the same result. So minus, taking into account rounding, 0.6 will become a 7. Done. So we can use the change of base formula, it's quite handy. Okay, 8, solving equations. Now we get back to using these guys for undo. How do we get to the x? We take the log base 3, and it undoes this one. What you do to one side, you do to the other. And so x has a value. That's a 1. So x is this value. But you say to me, oh, wait a minute, we can't do log 3 out the calculator. Yes, you can. You go log all then. So we'll have log base 10, 19 divided by log base 10, 3, which will be the same as the ln of 19 over the ln of 3. So the ln of 19 divided by the ln of 3 will be the log, so we'll have 19. You can't mix and match them though. Don't mix and match them, that won't work. So 2.680, so 2.68. So x has a value of 2.68. So if I take that 3 and raise it to the power of x, so I'm going to just put that into memory. 3 to the power, memory recall should be 19. Beautiful. So that was my check. Okay, I'll put the number in. 2.680143. Checked it. Okay, so you can do the same. Alright, part B. Why not? Is there any reason why we can't? 5x. How do we undo 5? Unusual question, isn't it? We take a log. And we get an undo. There it is. And that's also what you do to one side. Now, some students are not doing that. Be careful, please. Okay, x is equal to, now up and down, limit of 33.8 over the limit of 5 is equal to 33.8 1 divided by 5 is equal to 2.18738, which will be 2.19. Two decimal places. It becomes a 9, but we stop there. So it's very doable, isn't it? Very, very doable. Okay, so even when it gets a bit more interesting, you can put all these things into technology and they'll tell you the same thing. Okay. We can take the log base 5 to undo. Log base 5, that's undo. X plus 1, what you do to one side, you do to the other. So that's undo. So we're left with x plus 1. Log base 5, 31, subtract 1. So x will be equal to log base 5, 31 minus 1. So that's equal to that's right, we can put it in. Ln 31 over ln 5, subtract 1. So ln 31, so we'll do our practice. 31 ln divided by 5 ln is equal to, subtract 1. We get 1 point, we'll round that, 1, 3. So it's just undo. It's just undo, undo, undo. Okay. 3 times 7 to the power x equals 232. So maybe some pre-work's in order. Don't just do the multiplication there. Maybe just divide by 3. Maybe that's easier. Okay. So 3 8s, 3 7s are 21. With 2 left over. 3 7s are 21 again. 1 left over. Okay, how do we get rid of 7? Take the log base 7. What you do to one side, you do to the other. Okay, that's undo. Therefore, x is equal to the log 77 and a third to base 7, up, down. So that would be log base 10. Doesn't matter. I know you're asking why did I change it. Of course it doesn't matter. I'll do all that on the calculator now. It won't matter. Just don't mix match them. Okay, so clear all that out just to give you a breather from the mess. And then what we'll have is 77 and a third, 232 on 3, 232 divided by 3 is equal to, take the base 10 of that, thank you very much, divide that by 7 base 10, and we'll get 2.23. All goes down, so we'll leave it at 2.23. So they're very, very straightforward. Okay, gymnastics, that's all we're looking to do. So gymnastics, gymnastics, gymnastics. In each value, use the exact value. So don't, oh, no calculators. Oh, we'll love doing that. 3 log base 6 x is equal to 2. Can't do the loggy thing. Could divide by 3. Could put the 6 up there. Make it x 3. Could divide by 3 just to separate it. So either one would work, I think. I'm game. If you're game, we'll try. I want to see both work. So what do we do? Does it matter? That's the important thing. So if we do log base 6x to the cubed is equal to 2, or we could do log base 6x equals 2/3, dividing by 3. Okay, should it make a difference? Undo. So we take 6, everything up to the power of 6. That's your base. What you do over here, you do over here. Same here. 6 to the log base 6x. We're also going to lift that up to 2/3. This is undo. This is also undo. Same problem. So x cubed is equal to 6 squared. X is equal to 6. Now, those of you that are thinking will know that that's a cube root of 6 squared. Cube root of 6 squared. Okay, cube root of 6 squared. What about this one? X cubed, how do we do that? We take the cube root of x cubed. You do one side, you do the other. Cube root, so x will be equal to cube root of 6 squared. Same thing. Okay, which is 6 to the power 2/3. X is equal to 6 to the power 2/3. So either form, either strategy is going to get you to the same place. Okay, so don't fret those. So B is 5 log base 7x equals -2. Doesn't matter what you do. I'm going to do it that way. So log base 7 is x -2/5. How do I undo log 7? You ever going to get used to it? I hope you do. So that one came straight out, didn't it? No more. Well, I could do the whole 5th root of 7 squared, 5th root of 49, or I could leave it in that form. Your lecturer should give you an instruction if that's tested, or your system will give you an instruction as to what to do. Okay, log base 2. Log base 2 equals log base 2. So we can do the product, or we can subtract log base 2 to isolate the x, because that's sound strategy in algebra. So we've got log base 2, 21. You can see already what's happening. This is log base 2, 21/7. So log base 2x, log base 2, 3. You can already say x equals 3. Okay, just by equating, just by recognition, or equating, if the arguments are the same, x has to equal 3. Okay, you can stop there. That's enough. Or you can do it. It doesn't matter to me. Oops. That's undo. So is that. It's the same result. Okay. So just take your time. Do things carefully. Undo. 2 ln of x equals 5. Easy. How do we undo Lynn? Trying to trick us, aren't they? We're not so easy to trick. You leave it in that form. Okay. And the last one will be the same. B 3 ln of x divided by 3. So the ln of x raise is undo. Let's undo. Done. At this point you could unpack it, but it's probably just as easy to take these. We'll add e to both sides and subtract e, so I've missed a couple of steps there. So x is equal to 3 minus e to the half, which is 3 minus the square root of e. Okay, and the final one will be a similar theme, just a bit of gymnastics. That's all we're being asked to do. It's not rocket science, but it might lead you to rocket science. 3 ln 2 plus the ln of x minus 1 equals the ln of 24. So we can take the 3 up, I think. The ln of 2 cubed, which is 8, plus the ln of x minus 1, the ln of 24, so we take away the ln of 8, just doing algebra, objects, that's all we're doing. Ln of 24 minus the ln of 8 is the ln of 24 over 8. 3 8 is 24. Again, you're close enough now, you can say x minus 1 is equal to 3, or you can take the e's, doesn't matter. Undo, undo, x minus 1 equals 3, x equals 4. And that's it. That's the tutorial. Okay, so lots of work there, lots of students interacting and doing good work in the tutorials. Just be patient with yourself, work through them, undo, undo, undo. If you can undo and count, you can do university level maths. All right, bye for now.